Are we good? We're good. Okay. Setup assistant. Awesome. Google, I will allow you to be in full screen. Thank you, Google. All right, so I'm going to talk about something that has sort of tangentially related to Rosetta, but there are a lot of tools in Unix, in various types of this thing is not on, in various types of Unix that make your life a lot easier when it comes to like doing data analysis or like fixing up pieces of code. So I just want to talk about that. And before I talk about those, I actually just wanted to give you a brief timeline about Unix because I think it explains a lot of the sort of weirdness of some of the tools I'm going to talk about. So what Unix actually is basically a set of sort of loose and some very sort of tight standards and command line tools that sort of started in 1970. Unix was originally the Uniplexed Information and Computing Service. And then in 1977, Berkeley wrote a version of this called the Berkeley Standard Distribution. And then in 1988, the IEEE released this version of what they call the POSIX standard. And this basically gives you the compatibility between Unix-like operating systems. And this is why you can take Rosetta and compile it on your Linux box, and it works, and then take the same exact piece of source code and compile it on your Mac, and it also works. And that's because Linux and macOS are both variants of Unix. macOS is actually a variant of BSD originally. Linux itself started in 1991, and he started Linux because he wanted to have a version of Minix that was free, or something like that. I don't remember the exact story, and it sort of spun wildly out of control. And today people sort of use Linux, BSD, and various versions of OS X. So the point being that a lot of these things have been around for a really long time in computers, in the land of computers, 1970s sort of ancient history. So what can we do with this? And the other thing is that most of the tools I'm describing here work with all of these things. However, some of them are slightly different. So I tested everything I'm going to describe today on macOS, but if you have some other version of Linux, you might find that you type it in and you get an error. Which brings me to the first part of this. There are different types of command line shells. So when you've been typing commands and running scons and stuff like that, you've been doing that in a command line shell. It's basically an application for manipulating the file system and starting processes. And so Bash has sort of become one of the it's the most common, I think, shell at this point, or at least it's one of the most widely used and documented. It has lots of nice scripting features that I'm going to talk about. There's also ZSH, which is like Bash, except it's a lot more awesome. So it supports everything that Bash does, and then it has all these really useful features for writing functions and displaying really fancy prompts and tab completion. So if you are in an environment where you can install and use ZSH, I totally recommend it. Your Macs already have it installed.
Really?
Yeah.
Really?
Yeah. It's true. I think, is that true? Well, we're going to find out soon. But you should install it. And there's also TCSH, which is significantly less sophisticated than ZSH and Bash, but you find it on a lot of older systems. Yeah, go ahead.
So anything that I have in Bash now will run in ZSH?
Anything you have in Bash will run in ZSH, I think. No?
Nearly everything.
Nearly everything. I think that's the takeaway from this talk is nearly everything, right? Like, there are little inconsistencies between these things. And so TCSH is sort of older, and it's a lot simpler. And if you're stuck in the malware lab, if you're in the malware lab, you're stuck with it. And that may be cases in other large labs as well. So, yeah. But today we're going to be talking mostly about Bash. So talking about Bash, let's talk about quotes, which is a fascinating topic. So there's three different types of quotes in Bash. So if you put something in single quotes, it's treated as a string. If you put something in double quotes, it is basically used for enclosing variables or enclosing, sort of things in general. So if it's obviously a string, it'll keep it a string. If it's obviously a variable, it keeps it a variable. And then there's this thing called backtick. So if you put something in backticks, it'll take the contents of the backticks and try to run them as a process and then return the result. And if you're using Bash, you can do the same thing with $sign and then the command in parentheses. And since this may not actually make very much sense with me describing it, I thought I would make a little screencast here. So let's see how well this works. So this basically gives an example of different types of quoting, and it should just pop up at the bottom here in a minute. Okay, so if you say echo hello world in double quotes, it prints hello world. And then if you type echo hello world in single quotes, it does the same thing. All right, so that's cool. In this case, we're printing text. It's basically the same thing. Set a variable with hello in single quotes. Okay, this is going to be treated as a string. If we say echo the variable name, you put a $sign in front of it because it's variable, it prints it out. All right, now we say echo $foo, and it just prints out the name of the variable because single quotes mean the whole thing is treated as a string. And then, if we do it in double quotes, now we're just enclosing it, and so it parses it out as a variable again. So that's the difference between the single quotes and the double quotes. So single quotes, everything gets treated as a string. Double quotes, it just sort of encloses it, which is useful if you have like spaces. And Andrew's looking. Okay. So that's single quotes and double quotes. And all of these little screencasts, if you click on these links in your tutorials, you can play them again and again and again. It's wonderful. So you can also so one of the things that makes the shell really powerful is output redirection. What this means is you can take a command and take the output of it, instead of outputting it to the screen, you can output it to a file, or to another command, or to a file and a command. So there's lots of different ways of doing this. So each application, each probe command you run normally has two output streams, all right? There's standard output, which is just most of the sort of the normal output. And then there's standard error, which you're supposed to use for error messages. The reason they're different is because what this lets you do is, say, direct standard output, where maybe your data is going to a file, and then standard error to the screen. So the errors will show up on your screen, and the output goes to a file, or something like that. So we can redirect output to files. So if you have your command and then a caret like this, or a greater than symbol, and then the name of a file, it will output that to a new file, like this. So cat, basically, cat stands for concatenate. It will take the text, the file that you give it, and just print it to the screen. But if we have this little arrow here, it will instead print it to this file, b.text. All right, so this will actually create the file if it doesn't exist, or overwrite if it does. But what if we already have the file and we want to append to a file? Well, we'd use two of these greater than symbols. All right, so that's fairly straightforward. All right, so this is just standard output. If we want to do standard error, we do a to and then a greater than symbol. And if you do, an ampersand and then a greater than symbol, you do both standard output and standard error to a file. And then if you want to, instead of outputting standard output to a file, you want to output it to another program, use the pipe symbol. So what this command does is it takes a file, say a score file, grep searches, so it says basically search the file score.sc for the word score, and return all of the lines that have the word score in them. And then take those lines and pass them to this program called awk, which we're going to talk about in a minute, which will print the second word, is basically what this says. So you can sort of chain things together, and you can make these nice, really big, complicated commands with this, and take these very simple tools and turn them into much more complicated sort of data pipelines. There are other more obscure ways of redirecting output. These are the things that you're mostly going to do. If you search like bash output redirection, you'll see that there are about another like 6 or 7 operators that you might use, once a year. And so there's significant documentation for those. All right, so where is that significant? So there's a lot of documentation. And I talked earlier about how different versions of Unix have sort of slightly different implementations of some of these tools. So if you want to find out what it is for your system, there's this command called man. So I think every Unix command that you'll encounter has a manual page. So if you type man and then the command name, it will open up this page, and you can read it. And some of them are very useful. Man also has documentation of like the Unix C API calls. So if you're writing like an application that needs to hook into like Unix drivers, then you can get the documentation for it there, I guess, if you want to do that. But if you're confused about what a command does, type man command name, and you'll get a description of what it does. So that's useful. Right. So a lot of things that we do is we're trying to manipulate text. So I'm going to talk about a whole bunch of text manipulation command tools next. So there's grep, which searches for text using regular expressions. There's tr, which basically is a it stands for translate or transform. And it basically takes one piece of text and replaces it with another. There's sed, which performs more complicated transformations on a piece of text that you can define. There's awk, which is actually a real programming language that is sort of designed for manipulating text. There's also Perl. There's cut and paste, which are two commands used for splitting and combining columns of text. So a lot of times you have these sort of tabular data, and you want to take part of one file and attach part of another file in columns. And these are really useful tools for doing this. And I'm going to go and give you sort of simple examples of all of these. And none of these things are like concrete. This isn't like the beginning and end of it, right? You can find there's lots and lots of options for all of these things. It's just sort of the basic idea. So grep is a really powerful tool for searching text and its patterns in text, and it's really very fast. So grep uses regular expressions. So you can specify really so you guys have probably so far typed like star.txt or something to list all the text files. You guys familiar with that? All right. So the regular expression is sort of that idea, but much more complicated. So you can say things like look for. So you basically specify a pattern, and grep will search for things that match that pattern. So you can say look for things that begin with this word and end with that word and don't have this character in them, and it goes on and on. So I don't really have time to go into a huge amount of detail about regular expressions. I'll show you some examples over the next few slides, but there are entire books on regular expressions. Grep, Perl, Python all have slightly different regular expression syntax, but the basics are pretty much the same. And they're all pretty well documented on the internet. Grep can also search through directories recursively. So here's a bunch of good examples of grep. And I have another one of these little screencasts that I'm just can pull up. I think it's this one. Doing the screencast so you don't get to see all of the typos when I don't remember how commands work properly. So the downside being that it runs pretty slowly. So one of the things that sort of the most basic use of grep is, where does utility exit with message exist in this file? So I searched the file core kinematics foldtree.cc for utility exit with message and returned all the files. Then if you do grep-n, it also gives you the line numbers, which is really useful because just knowing where the files are in a source file isn't all that handy. And then the other thing you can do is this is the downside of the screencast thing. Didn't really think about this. Yeah, so here's an example of a regular expression. So and it ended, so I can actually explain what this does. So basically, what this is doing is it's searching for anything that's in quotes, right? So basically, the single quotes here are enclosing the regular expression. And then basically, so quote is an expression that means something in a regular expression. So I put a backslash. So backslash quote means, all right, search for a quote character. And then dot means any character. And then star means any number of the preceding character. So basically what this says is search for a quote followed by any number of any character followed by another double quote. And it's going to look in that for core kinematics fold tree. And it's finding basically, this is sort of running off the end of the screen here for some reason. But and then I basically only output the first few lines of it. So basically it's searching for all the text that's in quotes. So this is the sort of thing that you can do with grep. And there are lots more things you can do with grep, but that's sort of the basic idea. But a lot of the things you do with grep are really you want to figure out where something is in your giant set of source code. So the command, search all of the cc and hh files for the word fold tree in this directory. This should say ack fold tree. But basically there's this command called ack, which was designed sort of with the recognition that really mostly what people do with grep is search for words in source code. So let's see. Here's an example of how this works. This is not. Oh, what was that? This is not a standard Unix tool, but you can install it really easily. Basically, you just type ack and then the name of a word or some regular expression, and it just rolls through your entire directory, and it searches for cc, hh, Python, common source. Common endings for source files. And you can customize what it looks for. And then it's really nice because in each file it gives you the name of the file, then all the lines where it occurred. And you can specify regular expressions if you want, and it's a very nice way for quickly looking for something in your source directory. And this just goes and goes and goes because there's lots of fold tree. And then later I decided, I'm going to search for anything with the word pose and then something after it. So you can search with regular expressions too. And it highlights in yellow the parts that it actually selects, which is nice. So yeah.
Speaking about shell, how do you get your Git branch displayed?
Oh, yeah. So you get your Git branch displayed. The easy way is to install ZSH and then install a package called omyzsh, which is basically the set of plugins and fancy-looking shell prompts. And if you go to the Rosetta wiki, there's a big thing that in red text that talks about the GitHub transition thing. If you look at that and click on the workflow thing, scroll down to the bottom, it's got instructions on how to install it. It's super easy. And yeah, so this I have it set up so it displays what branch I'm in, which is really useful because it means then you spend less time writing code in the wrong branch. So that's ACK. Then there's TR. Oh, I guess I figured out what it stands for when I wrote this presentation. TR stands for translate. And so basically TR will replace or delete characters from an input file. And it takes input from standard input. So if I say TR, and then space, and then \T is the character for a tab. And then this little thing means instead of basically, before the other arrow means basically take the contents of the thing, of the command, and put it into a file. This means take the contents of the file and put it into the command, right? So it'll replace all of your spaces with tabs. This will delete all of your new line characters. So you can do things like that. This is straightforward enough that, well, I have a little, do you want to see the screencast? I can just leave it as a reference. I'll just leave it as a reference. But yeah, so that's what translate does. Then there's cut and paste. Cut and paste are really, really useful. So what cut does is it prints a column, basically, if you have a column or some range of characters from a file, and it just prints that to standard output. And paste then takes multiple files and combines them by column. And this is better shown than told. Let's see, cut and paste is here. All right. Those web links, you can change the speed, so you don't have to sit there and wait for a while. But so basically, a lot of the data that we deal with is tab or light space delimited. So here I have a little file called 2 columns. They're separated by tabs. So if I do cut-F1, it takes the first field. If I do cut-F2, it gives me the second field, right? So that's fairly straightforward. So I can get one column of text from 2. All right, now let's look at paste. So I have two files now. They each have 1 column. Column A has these 3 things. Column B has these 3 lines. All right, so I can combine them together by just saying paste column A, column B, and it sticks them together. And this is a really simple way of doing something that's otherwise actually fairly frustrating to do. So now the other thing we can do is we can combine cut and paste directly, and that's the next thing here. So going back to this 2 column, let's switch these 2 columns. So we want 1, 2, 3, 4 to be first and A, B, C, D to be next. So here what we've done is we've done cut, and what this is doing is basically run this command, and then so basically what it does is it runs this command and then runs that command, and then this shouldn't actually be here at all, and that's sort of some sort of strange corruption in the screencast program. That's odd. And then it will combine them like you did here. So you can take one file and just swap the 2 with 1 command. So does that kind of make sense to people? And yeah, so cut and paste are incredibly useful because doing this with Python would be like 10 lines of code or something, and it's just pretty much people have been having this problem for 30 years, so there's a good solution to it now. So yeah, there's also find. Find kind of does what it sounds like. It finds files in a directory, and it does it recursively. And if you do man find, there's just dozens of options for ways of searching for files. Name, owner, modification date. You can find files that were modified in the last week and stuff like that. But really, mostly what people do with it is things like this. So here's another sort of a good example. We can do find here. There's something I'm typing there. There we go. So basically, you give it some, and it actually searches by regular expression. You give it a directory you want to start from. You give it some thing to search for, and it will start playing the wrong thing. It's this one. Yeah. So let's see if this does what it's supposed to. Yeah. And this is really useful if you're looking for a file or you have a whole bunch of nested directories that all have PDB files in them and you want them. So here we have in the current directory find all the CC files, and we're piping into a command called head, which just prints the first few lines because I want you to actually see what's going on. Find, so dot is the current directory. So in the current directory, find all of the empty files, and here we see a bunch of empty pilot applications for some reason. And then here we can say dash type D gives you all of the directories. So you can see if you're looking for certain types of files, this is a useful way of doing it. Yeah.
You often would find I know that this file is below the directory I'm in. I just can't remember which directory.
Right.
How do you search all the directories beneath the current?
It does it. This does it recursively. So this actually is searching all of, you're in the source directory, and it actually is going. If you had just let it go like this, I can. Yeah, we can just, if we don't include head here, I'm not in the right directory right now. But yeah, so it by default searches everything recursively, which is cool. Deep. All right. So now I'm going to talk about a few sort of simple text parsing languages. Sed is probably the simple of them. It's called the stream editor, and it's really good for things that are just a bit more complicated than translate. Yeah?
No, I just want to say that find also has very big functions.
Yes. Find can also do things like delete files as it finds them, which is probably something that you... And so this is another thing about Unix tools. They don't ask before doing things, right? So most Unix tools don't say, like, are you sure you want to? They just sort of make the assumption that if you typed it, it's because you wanted it to happen. So that's true. The things that let you recursively search your directory and delete files that meet certain criteria are a good way to... Also, backing up things is disk space. These hard drives are cheap. You can, but don't, yeah. You can get yourself in trouble.
But we can always make any of these commands if we are really that paranoid, we can make them all interactive, right?
Yes, most of them. I'm not sure if find has an interactive mode. I've never used find to delete files because it just seems like such a terrible idea. Right. So here we have some more examples of regular expressions, but I'll just explain to you what these things do, right? So, all right. Sed, basically, you give it some type of text transformation and then a file name, and by default outputs it to the screen. So what this says is S means, all right, search, and then replace the thing in the first set of bars, slashes, with the thing in the second set of slashes. And the G means do that line by line for every instance in the line. If you leave the G off, it'll just replace the first instance in each line, which may or may not be what you want. And the cool thing about these slashes is they don't have to be slashes. They can be any two characters. So if your search have a list of directory and it's like, oh my god, it's full of forward slashes, you can use pound signs or something. You can use any symbol you want, which makes this sort of thing really, really straightforward. So this replaces every instance of foo with bar.
So can you repeat that? So the way I understood it, could I just put S hash foo hash bar and then just do the thing?
Yeah. Oh. Yeah. Let me. I don't actually have a demonstration of this, but I can just, we have this sed demos thing here. And, all right, there's this line with foo in it, so I can say sed s r, let's say, like 4, right? What's up with that? Man, that's all kinds of weird. Can you make that, oh, maybe if I make it unfull screen and then full screen it again. There we go. That's weird. All right. Huh. All right. So we can do something like, sed s plus foo plus bar plus g. So any character works. I think you can literally use any character, but I'm not sure what the limitations of it are. I did. Oh, so when I change...
No, it was lost after the output got.
Really?
Yeah.
We'll just not full screen this. There. That good? Yeah. All right. So
Does hash really work? It's not a comment.
I don't think so.
Hash will work.
Hash will work.
Yeah.
I think actually, will any character work? I think any character will work.
It has to be the same.
Yeah. If you hate yourself, yeah. So it's the first character after the S, and yeah. So yeah, go ahead. Is someone? Yeah. Okay. Right. So and you can actually get where'd my there it is. You can get pretty complicated with this. So what this will do, this is a regular expression. So the square brackets mean, this is basically saying is match any number of spaces or tabs. So the square brackets mean basically space or tab, any number of them, and the dollar sign means at the end of the line, and replace it with nothing. So this will remove trailing white space. And so what's really weird about this, because I did this, in OS X, and this is what happened. Let's just, so I can just tell you. In OS X, because OS X is a type of BSD, for some reason, the version of sed that comes with OS X will recognize /t as the character T rather than the tab character. So this will remove spaces or trailing T's in OS X. So if you want a tab, what you do is you hit Control V and then the tab character. Dash P will do that too? Okay, all right. Yeah, that'll work too, I guess. So that's cool. And then this will basically delete empty lines. So caret means beginning of the line. Dollar sign means the end of the line. So if the beginning of the line is right next to the end of the line, then it will just delete it. So you can do all sorts of useful things with sed. But you can't do everything with sed. So then you're like, well, it's a pain in the butt to do it sed. I'm going to do it in
Is it possible to match binary files?
What?
Is it possible to match things inside of binary files?
I don't know. I've never tried that.
Okay.
That's you let me know. I don't know. So awk is actually like a programming language, like a real programming language, and it was really designed for like extracting parts of strings, and it's really useful for doing that. And it's a full programming language, so you can write large scripts in it. But having once inherited several lines of awk, I would really recommend against this. There are better languages to do large tasks in. But if you can do it in like 80 characters of awk is great. And so let's talk about awk. And this is something where the screencast is actually probably going to be useful because there's all sorts of cool things we can do with awk. And because a lot of Rosetta's output is text, it's good for sort of simple data analysis tasks. So I made a little really short score file that just has, here I've catted it. It's got the header, and then it's got basically one or two identical score lines. So if you say awk print $4, it prints the fourth field, which is FA rep, and it does it for every line. So these two lines are just copy pasted, so you get that. Then what this does is it says, okay, take the fourth field, add them all up, and print the sum. So now I've added the numbers in the fourth field, and I get the sum of those. And then what you can do is you can say, okay, I want to add all of the scores except the total score. So this is field 1, field 2 is the total score, and then field 3 here. So you say basically S is a variable, and this is a for loop. So go through number 3 up through the total number of fields and add the current value to S, and it will do that for every line. So you can sort of get a total score. And the reason this total score is not the same as that total score is that this file just has the single body energies in it, which is sort of a Rosetta score file thing. And you notice it did this for every line. So that's why the first line here is 0, is because this is all strings, and strings have a value of 0 in awk. If you try to treat them as integers. So these are sort of some of the many things you can do with awk. And there's lots of documentation on awk. There's also whole lists of like awk one-liners, and I actually have a link to one of these on the back, where there are a lot of things that people just want to do in awk, and you can just find the thing and copy paste it. Yeah?
I think the reason it's not adding up is because you have to be running this time.
Oh, that might be it too. But it is the case, or is it just the PDB file? It's the PDB files that do this, that just for the per residue energies, just print the single bodies.
I think it's maybe the backbone.
That's the one. Yeah. Okay. So this is because the runtime is there. I didn't even notice that. Thank you. So yeah. So that's sort of some of the things you can do with awk. All right. And then there are even more, there are things that are maybe too complicated with awk, and you're like, okay, well, I'm going to use Perl. Perl can also do one-liners. Yeah?
Can I just share one of my feelings about it?
Yeah. But only one of your feelings. Do you have complicated feelings about this?
So if I can do it in one line in awk, I will. But if I do it in more than one line, you still will. You do it. I don't.
Yeah, I agree. I agree entirely. Awk is best used for things that can be done in one line of awk.
Then if I need to do more than one line, then I do it in Python.
Yeah.
Maybe you can go through Perl. Try Perl and then go to Python.
Well, so the Perl one-liner slide was a special request, I think, from Matt. Because people forget that Perl, I think you suggested this. Yeah, so people forget that Perl can do one-liners, and it can.
Really?
So there are three options that are useful here. So if you do Perl-E, it'll run the rest of the command line as code on the command line. If you do Perl-EN, it will do this, but it will run this little snippet of code once per line of input, which makes it kind of behave like awk does. And if you do Perl-E or -E and then P, it will do the same thing as -N, except it will also print every line out, so which saves you from having to type print, which is nice. So what does this do? Anyone familiar with Perl? Okay, so I'm not familiar with Perl either, so I just found these on the internet, and they seemed like good examples. But basically what this does is it takes a file and it makes it double-spaced unless the line is already a blank, right? So the way it does this is the input, $_
That's the input.
yeah. And
that's the current.
that's the
current
Right.
non-name variable.
So Perl has this concept called the current variable, which is basically if you pass in a parameter to a function, it goes in $_. So this is the current variable. Yeah, this is part of what makes Perl so readable.
It's really
No,
awesome.
but you should never use that.
And then what it does is so you're running PE, right? So it's going to run this code once per input. So it takes the current line, adds a /n to it.
What's the dot?
Dot equal basically will take this and add it to the end.
Animation.
It's a concatenation. Yeah. It's like plus equal in C++ with strings, right? Except it's a dot. Plus equal, I think, does something else. Or
No,
plus equal does the same thing?
it's the same.
Okay, all right, cool. Why not have two? And then it'll add a new line, unless the line is empty. Slashes mean you're matching a pattern, and the pattern is a new line followed directly by the end of the line. So there we go.
So
All right.
somehow implicitly in that is the fact that you're comparing $_ against.
Yes. Yeah. Right. Because it's right. The $_ is implicitly compared to this. That's correct.
That's what we call magic.
Yeah. There are other longer ways of doing this. Right. Because you can. And in fact, you guys had a FizzBuzz experiment, like homework assignment, right? So I also found on the internet the shortest known Perl implementation of FizzBuzz. And this has gone off the line, but this is .100. And it works, I tested it. So it's 48 characters, it's the shortest one. There are contests for this. What? The knowledge of a job well done. So that's Perl. All right, so let's stop talking about text editors and talk a little bit about job distribution. So shell commands actually have maximum length. So if you type *.text, right? What the shell does is it takes the star and takes that star and it expands it out. So it replaces it with all the files that match *.text and puts some spaces in between, sticks them out. But eventually you have too many, and then it will say something like command line too long. And this is terrible because all you wanted to do was gzip all the PDB files in your directory with 1 million PDB files in it, and now what do? Well, you can use things like xargs in parallel. And so what xargs does is it takes this long list. It takes a long list as input. And it splits it up into little sublists, and it executes each command, and it executes a command and gives it that sublist. So let's say the thing that I use this for a lot is I have a whole bunch of, I don't know why I said CC files, I have a whole bunch of output files or PDB files or whatever in a directory. So in the current directory, I say find dot -name star.out. So this is going to find all of the files that end in .out. I'm going to pipe that big list to xargs. I'm going to give xargs the name of an executable, in this case gzip, and xargs is going to split up this big long list and then give little short sublists to gzip one at a time, and gzip will just go and execute them. So this is useful for handling lots of data at once. And this will do run on one thread. So parallel is really similar to xargs in its syntax, but it will actually execute the sublists in multiple threads. So if I do this, basically does these two things do the same thing, except this does it on 8 cores, or however many specified J with. Yeah.
So you can run grep too.
Yeah, yeah.
So this is like a distributed.
Right. It's like it'll distribute arbitrary shell commands, and there's actually a lot more you can do with it than just this. This is like the simplest possible use, and there's a whole websites dedicated to increasingly more complex things you can do with GNU Parallel. But the simple things are actually really useful. This isn't installed by default, but it's really easy to install. I don't even think it has any dependencies, so you can install it from source or from your favorite packet manager. I really recommend Parallel. It's very useful once in a while.
Wait, does it still have like the -0 option?
Yeah, it has actually that plus they've extended. So if you have, so gzip is easy because it has takes one argument. If you have things that take multiple arguments, there are various options for sort of figuring out, where in the big long command line do you put the sublist that xargs is giving it. And so if you read the manual, I didn't want to get too far into that, but it has syntax for sort of formatting these command lines, and Parallel has an even more complicated syntax.
So if you wanted to tar up a whole bunch of files.
Yeah, into one directory?
Into one tar disease.
I don't think so, because tar is sort of a serial format, right? This will do it. Will Parallel do each one separately? I think Parallel only does things that are embarrassingly parallel,
Well, I mean,
but
xargs might be something where you would want to.
I think xargs you would end up xargs if it was just tar. Yeah, xargs you could just keep appending to the end, right? But I think Parallel has to do things that don't talk to each other. But knowing people who write Unix tools, it's entirely possible there's some arcane way to make this thing handle that properly. I've never looked. Yeah. All right. There's also a little bit of stuff about process management. If you take a command and you put an ampersand after it, it will execute that process in the background, so you can keep using your terminal. And so this is frequently useful if you have something that's going to run for a while and you don't want to open a new tab and you just want to do something else in the meantime. If you take a command and then ampersand, and then another command, it will execute the first command and then only execute the second command if the first command completed successfully. So this is useful when you want to do 10 things in a row, but if one of them fails, you don't want to keep going. So you can use ampersands.
Exactly the AND operator.
Right, it's just, that is precisely what it is the AND operator. I believe there's an OR operator too, which I've never come up with a reason why I would use that, but you could. For chaining commands together. It's useful for other things. Or I guess you could.
It will run the first one and then it will run the second one, even if the first one
Right.
doesn't die.
Yeah.
Well, maybe you need 3 things.
Right, you would do 3 things, and you want at least, you at least want one.
At least one.
Yeah. And if you use a semicolon, if you have command, semicolon, command, it'll execute one command and then the second command, even if the first one fails.
What I like the ampersand for, if I can give a little anecdote,
Yeah.
is I check out master, and I run scons.py, and then I cd into
Yeah.
Rosetta tests integration, and then I run integration.py-j24, accept changes, cd ... Rosetta source, check out my new branch, scons.py, cd ... Rosetta tests integration.py.
Right.
And then I hit enter.
And then you go to lunch.
And then I go and I
Right.
and I come back and now I've got the difference between my branch and master.
Right.
And it's just all set up. And so, I mean, because you got like something that it's going to take a couple minutes, and then you're going to type another simple command.
Right.
It's just, well, the only, an ampersand will stop if for instance, master doesn't compile. And so it won't go on and then act as if nothing. But it won't let you deceive yourself into thinking that your integration test actually succeeded, because it will stop before the integration test. That also means if you do go to lunch and master doesn't come back, you won't have gotten
Right. But you wouldn't have anyways because it didn't compile. Yeah. So you've backgrounded your process by adding an ampersand at the end, and then you want to figure out what it's doing. So you type FG and it comes back into the foreground. So that's useful. Then the other thing you do is you're on an SSH server, and you're like, oh, hey, I just want to start this process and then close my window. So you type no-hup, which stands for no hang-up, which is sort of a relic from the 70s in terms of terminology. And then you type the process name, and then you type ampersand. It runs it in the background, and will keep running it even after you log out. If you just use ampersand, it's still attached to the user. Yes?
I think that is one of the worst comments in the world.
It is. And then if you run this on a cluster, you might get shot by your system administrator.
If
Never run before.
you have to run that on a cluster in not graphical mode, no problem.
No. You can send the error to the new device. But you don't need
Yeah,
to do
that's-
that.
that's,
That's
Yeah.
the worst.
It was a special request. But I don't think it's the worst command in the world. If you want to talk worst commands in the world,
Yeah,
It's
there's a lot.
not a great command. There are two reasons. The first is that there's an alternative which is better.
right, which I'm talking about.
Yeah.
Screen? Yeah.
And then the other is that
Screen.
if you SSH into a server, at least on the terminals that I've used on Mac, which is iTerm mostly.
Yeah.
And you run a process no hop, and then you type exit,
Right.
so that you can get your terminal back.
Yeah.
Your command prompt never returns. That terminal's now dead. If you have a history in that terminal,
Right, it's gone
you
now.
can't hit up arrow and get to it anymore.
Right.
I don't like that.
So, yeah, there may indeed be still a legitimate use case for a no-hub.
No, I think
Or not. Okay.
it's a lazy command.
I've never used it, but it came up as something that I might want to mention. The other thing is, so you have a list of processes, and you did this one with no-hup, and then you're trying to kill it. If you type PS, you get a list of all of the processes, and the first column is a number. And then you can type, say, htop, and then htop is a nice little command that will show all the things that are using your CPU in this nice little pretty graphical way, like htop. What? Okay, I guess I don't have htop installed. Let's go to a different machine. htop. Okay, so there it is, right? And I'm not, my workstation in lab is doing nothing. So that's htop. It's really nice. It shows you your memory usage and all your little processors. And how cool is that? htop. It's a much prettier version of top. Top is like this. Top is installed everywhere. htop is not installed by default. But if you can install it, you should because it's much easier to use or read. All right. And then PS. PS gives you a big list. And if you do PS AX, it actually lists all of the processes that are running on your computer. And then this is the process number. And then if you type kill and then a process number, it will kill that process if you have permission to end it. But I'm not going to do that. Yeah, kill process ID. So if you have something that just sort of goes haywire and you want to get rid of it, you can kill it. If you do that and it doesn't die, you type kill space -9, and then it kills it much more aggressively, and that's usually good enough to end processes. All right, so let's talk about bash scripting, because you guys have an actual little thing associated, an exercise associated with this. So a bash script is in its most basic form. It's a big list of bash commands in a file that you've made executable. All right. So the cool thing, though, is you can pass in command line variables as arguments, and they have variable names that are, the first one is $1, the second one's $2, 3, 4, etc. for however many command lines the user gave you. And you can also define variables within the script. And so the way you use bash scripting is when you're doing something where the easiest way to solve it is with lots of different Unix utilities, but it's way too complicated to be a one-liner, then you can use a bash script. And so you can do if statements in bash. So here, the simplest one, if you have a variable that's it's a Boolean, it's okay up. The syntax here is a little bit.
You can use Python as a shell.
Yeah.
And same with Perl.
But there are some things that are actually easier to do in bash than Perl or Python. But so if you have a Boolean, you say if the Boolean variable, semicolon, the semicolon is needed, and then you say have the contents of your if statement. Then you end your if statement with the word if backwards.
You see, to use this, I have to remember how to do that.
And then let's say you don't have a Boolean, you want to do some comparison. So I want this to be true if the variable string is equal to bar, the string bar. So I do this. And you'll see I have these spaces here on either side of my square bracket. And these spaces are required, and the reason they're required is that open square bracket is actually the name of an executable. Which is why if you type just square bracket, it gives you the thing like a syntax error, right? Because this is actually a program called square bracket, which I think is amazing. So you really do need these spaces. So let's say you have a number, and you want it to work if the number is numerically equal to 5, right? Then you do dash EQ. Greater than is dash GT, less than is dash LT, and there are others. You can also have if and else if. So you do if, then elif, then the space isn't here, and then else, right? So this is kind of, and then you have a phi at the end, which Google cut off for some reason in presenter mode. You can also do loops. So in a loop, you can do something like this. You can say for value, this is the variable that you're making in 1, 2, 3, 4, 5. You've made a list. And then do, note the lack of semicolons here. It's very consistent. So this will print out 1, 2, 3, 4, 5 on the screen. You can say if you have a variable that's a list, you can do the same thing. You can have $list, and then it'll print all of the values in $list. If you want to run a command that returns some list of things like, an ls command or something, a list a bunch of files, you can do this. It'll run the command and then loop through all of the things in the command as a list and print them out. All right, so that's cool. So here's an example, and this is actually a real-world example. Whenever you make a commit in the Git repository, it actually runs this script. So I can just go through what this does. So the first thing, we've got these backticks here. First, it runs the command uname to figure out what operating system you're running. That's what uname does. And it'll print out either Linux or if you're running Linux, or Darwin if you're running OS X. And then it runs this big git command. And basically what this does, it returns all of the file names that are modified in the current directory. So these are the modified but uncommitted. So these are the things you're about to commit. And it puts them in a list, in a variable called files modified. It loops through all of them. Now what we're trying to do here is find big files. The way we do this is with this command called stat. And stat is completely different in Linux and OS X. So if it's Linux, you type stat-c and then in quotes parentheses s in the current file, and that gives the size. Whereas in OS X, it's -f %z. So great, OK. And then this will give you the file size. And then if the file size that does it in bytes, so if it's greater than 2 million bytes, then it prints out a nice little warning. And it does this for every file, and then it exits. So this is a bash script. And you can do a lot. So, as an example, like this script in Python would be significantly longer and would also require that Python was installed, and would probably require actually just either having the git Python module installed, which isn't installed by default, or using like fork or subprocess or something like this. So things like this are actually, I argue, best done in bash. But people might disagree with me, and they can do that. OK, so cron is another useful thing. Cron basically executes commands on a schedule. So you have this program called cron tab. When you run cron tab, it opens up a special editor, which is really just Vim. But what it does is it keeps track of, you basically make this file. And so the file has a bunch of these fields. Wikipedia has this nice little piece of ASCII art. So the first field is the minute, then the hour, and then the day, month, week, and then the whole command you're going to execute. So for example, and star means do it on all of them, right? So if you said something like, if you just had **0, that would mean, run every Sunday, run this command. Or you could say, if you put a 5 here, every 5 minutes run this command. Or, every March the 3rd, you can run a command. So if you have something that you want to happen automatically, periodically, it will just do this. Yes?
Can I share a feeling about it?
You can share a feeling about it.
This is like a really good way to avoid friction with your systems administrator.
Yeah.
Because instead of bombing the queue when you try to leave at 5 p.m.,
right.
you can just set up a cron tab that'll launch at 2 in the morning when all the cycles are just open, and then you get all your stuff done and it's ready for you in the morning.
It's cool that way. And yeah.
I was curious, if the machine somehow stops, does the cron, is there a memory, or do I have to put it in the startup so that even if there's
it starts, I believe cron starts at boot, so.
Cron starts at boot, so I don't have to worry that the machine will stop.
I don't think so.
It also executes in its own shell.
It runs in its own shell, and it runs as your user. So, yeah.
So do you need your computer or other computer? No, like whenever I get the command, like whenever I'm running.
When you boot, the cron daemon should start, right?
Yeah. If there is Cron daemon, it will run.
Right.
You have permission.
I'll bet there's some weird system somewhere in the world where that doesn't happen, but I've never encountered one. The other cool thing is screen. All right, so instead of showing you the slide, I'm just going to do this. And I don't have a screencast because it wasn't working very well. But all right, so here I'm logged into my computer in Nashville. So I'm going to type screen -r because I actually think I already have a screen attached. Yeah, and here it is. So the last time I was using screen, I was running this big long script that took like 7 hours to run. And I didn't feel like using NoHub because, right. So I ran it in screen. And then when I was done, I typed Control A and then D, and it said detached, right? And now I'm back to this other shell. What? And then if I type screen-R, it reattaches it. And so this is basically a terminal. But the cool thing is I can, within this one screen, have multiple terminals. So if I type Control A, C, now I have a new terminal, and I can do something in it, logs. All right. And then I can type Control A, these are numbered. So Control A0 will go back to my last one. Control A1 will go back to the one that I just made. If I'm done with this, I can type exit. This one will close, and the other one will remain. So this is really useful for when you're connecting to your remote machine, you're sitting in a coffee shop, and you have to close your laptop, and you're like, oops, I was running something for 5 hours. If you're running in screen, it'll just keep going without you, and then you can just reattach to your screen and pick up working where you left off. It's a really useful tool. Yeah? Did you have a question? It is so much better than NoHub. There's another thing called Tmux, which is even better than it, but it frequently isn't installed. Screen is on pretty much everything these days. So Screen's great. Use Screen.
I have a good example of how to use Screen, which
Yeah.
may piss off people. But if you can do interactive jobs on your cluster, start a really long interactive job in Screen. You can test the job at any time.
Does your cluster not have a huge ASCII art, if you run interactive jobs, we'll murder you warning when you log in? Wow. I didn't know. Yeah, most clusters don't like you to run things in interactive mode. So yeah.
We can do that to test.
Oh, okay.
Yeah.
So that would be
Leave
what.
one
Yeah.
open for a very long time.
That's mean. There's also the other thing talking about terminals. There's a thing called SCP. It's called secure copy. The syntax is really similar to copy, except what it does is we'll do it between your computer and a remote computer. And the only requirement is the remote computer have an SSH server, which is cool, right? So use this like you would use FTP, except instead of FTP, because FTP is old and busted. So if you're running an SSH server, you can just do SCP, path to some text file. So this will copy this text file to your remote server. So you have the username at server name, and then the path on the remote server you want to copy it into. You can also do directories. This will copy the contents of the remote directory to a local directory. So it's just like copy, except it does it over SSH. So if you want to move files back and forth between a computer and some other computer, this is a really good way of doing it. And so for further resources, there's a bunch of links here. A lot of the things that you might want to do with sed and awk, someone else has figured out what to do. So instead of reading the documentation, you can just Google until you find someone who has read the documentation and copy their solution. You can do the same thing with awk. And then here's some, if you really want a big long book about bash scripting, this is a big long book about bash scripting. And so I've got a tutorial for you guys to do. It's 2 exercises. They're both pretty open-ended. And what I wanted to basically, there are a lot of ways to do these. I have demonstrated enough tools for you to do them. I will say that I want you to do them both as bash scripts. So you could do both of them with Python or Perl or C++ or something, but do them as a bash script instead. But other than that, you can do it any way you want. And there are solutions to both of them that are pretty short. So if you find yourself, these aren't 100 line of code type things. They're if it ends up being 100 line of code, that's cool too. But they can be done pretty concisely. But other than that, I figured I'd make them pretty open-ended because for any one of these things, there's a million different ways of doing it. So the choice is yours. And all of the stuff that I demonstrated is sort of OS X syntax. If you're not running OS X, look at the man page if you get weird errors when you try to run the example commands. Any other questions? Yeah?
What's the problem with NoHub?
The problem with no-hup is that basically you start a command and then detach it, and then it just sits there running with no control from anything forever, and may or may not return control of your shell properly when you exit. And is that basically the extent of it? Sometimes it just doesn't work. And you should really just use screen anyways because it's probably installed and it's better.
It takes out the program from the scope of the kernel. It's horizontal.
Right.
You can use zombies from time to time.
Produces what?
That you cannot, zombies.
Some what?
Zombies.
Zombies. Oh, right. So you can end up with a process that nothing can get back.
Right?
And it's just there and running.
Accumulates there forever.
Right. And then your system administrator kills you.
Yes.